Oh, you chose up.
So let's do a long division, right? Let's do x plus 4 into 2x cubed plus 5x squared
I remember doing this last year too, but I don't remember anything.
minus 6x plus 31. Now, one important thing, which I think I forgot to mention yesterday, is that you need a placeholder for every power, right? Because when you go and you multiply, things need to line up. So when I say, okay, x goes into 2x cubed, 2x squared times, or usually I just ask, what do I multiply this by to get this? Right? Which usually just means take this divided by that, and so it's 2x squared. When I multiply that, I'm going to get an x cubed term and an x squared term. If I don't have an x squared term here, I need a placeholder, so I need to put like a 0x squared. Okay? So in any division, long division or synthetic division, you need a placeholder for each power below the highest. So if I have a cubed, then I need a squared, an x, and a constant. And if they're not there, then I just put in a 0. Okay, so what do? We multiply 2x squared times x plus 4, giving us 2x cubed plus 8x squared. Draw the line, subtract. Negative 3x squared. Negative 3x squared divided by x is minus 3x, right? And the whole idea is we want to get rid of this first term, right? And now we want to get rid of the minus 3x squared. So we just make sure we have the exact same term. And we multiply, oh, and I got to bring down, right? So bring down the 6x, and gives me minus 12x. And we subtract, giving us positive 6x. Bring down the 31. 6 plus 6 gives me 6x plus 24. And we subtract, and we get a remainder of 7. Okay? So that's what we're looking at, right? The remainder of 7. Now, let's say we take this, and we're going to erase all of the x's. So I'm going to go up here. Except I'm going to leave this one here just to show what I'm dividing by. But, I'm going to erase all the x's.
Oh, I remember synthetic division now. Yeah. I remember doing this.
I need like a smaller eraser.
Remember, it's like the line thing, remember? Oh, yeah, the cross thing.
Okay, I'm going to rewrite this without the x's, because I just can't erase them. So. Okay, so what you're looking at in front, what you'll be looking at is, and I will leave the x here, just because I kind of like it there. So without the x's, this will be a 2, and then we got a plus 5, and we got a minus 6, and we got a plus 31. And up top there we had a 2, and a negative 3, and a plus 6. Okay? And then down here we had a 2 and an 8. And when we subtracted, that gave us the negative 3, and then we had the negative 6. And then under here we had a negative 3 and a negative 12. And we subtracted, giving us a 6. And then we had the plus 31. And then we got the 6 and the 24, okay, which was a plus 24, and it gave us a 7, right? So all I've done is I've just erased all the x's, right? There's no x cubes, x squareds, nothing, right? It's just the numbers are in their placeholders there. Now we can erase the lower duplicates wherever a number is subtracted from itself. So by that I mean we can get rid of the 2 here. So this I might be able to do. Okay. So the 2, this minus 3 down here, and the 6 down here, right? So I've gotten rid of the duplicated numbers. And now, let's get rid of the bring downs. So I brought down the 6. And I brought down the 31. Okay? So now we've got negative 3, negative 4, yeah, 6, 24, 7. And that leaves us a bunch of room, right? We could close things up a bit, right? If we didn't have to do all the bring downs, we didn't have all the x's, we didn't have to duplicate the stuff that's being duplicated. So that would allow us to write it like this. So I'm just going to leave that x there on the divisor, right? But we would have a 2, a negative 3, and a positive 6. And here we have the 2 and a plus 5. And a minus 6 and a plus 31. And here we have, we're just going to, so the 8 goes underneath the 5, right? We get the 8. and we're going to bring that up there. So we got a minus 12, and we get a plus 24. Okay, and then down here we have, and we'll just bring those up, right? So we've got the negative 3, the 6, and the 7. Okay, so we're compacting this, right? Now, everything we need is kind of down here, right? So, but this introductory 2, let's bring it from here down to here. Okay, so we'll move the 2 down there. Okay, and that means we can get rid of all this. Okay, because those numbers are just down here anyways, right? So now we have x plus 4, and we have a 2, and a plus 5, and a minus 6, and a plus 31. And under them we have the 8, and the negative 12, and the 24. And underneath now we have the 2, the negative 3, the 6, and the 7. Okay, so this is what we're going to do for synthetic division, is just collapse the whole thing down so that we're writing it on basically kind of 3 lines, right? So here's how we do a synthetic division. Let's go to a new thing. So what was the original problem? The original problem was 2x cubed plus 5x squared, 2x cubed plus 5x squared minus 6x plus 31 divided by x plus 4. Okay? So we set this up, we did a long division on it, yay. Okay, but now we want to, now we've seen that, hey, if you eliminate a lot of the duplicate stuff, you don't need to write the x's, you don't need to write the bring downs, you can collapse everything up. So here's what we're going to write. So I'm going to keep the x plus 4. I'll keep that x there. Okay? We're going to then write this as, yeah, we're going to draw an L. Like so. And now we're going to put down the 2x cubed. So this is my x cubed term. This is my x squared. This is my x. This is my constant. I'm not going to write plus signs now, right? I mean, if there's no sign there, it's plus. I will write the minus signs if they're there. Okay? So this is what we're doing. So we're going to bring down the 2. Now, we're going to go 4 times 2 is 8. 5 minus 8 is negative 3. We're going to go 4 times negative 3 is negative 12. Negative 6 minus negative 12 is positive 6. 4 times 6 is 24. 31 minus 24 is 7. Now there's our answer. Now here's how we read it. This is the constant term. Okay? Actually, sorry, no, that's the remainder.
That's a constant, guys.
That's the remainder. This is the constant term.
Gay.
Isn't that recorded?
This is the x, and this is the x squared, right? And then you keep going. If there's more, then it's x cubed. So it's remainder, which if it's 0, then we know the thing's a factor of, right? But if it's not, then all right, we'll deal with that. So we have a remainder of 7, and the quotient then is, so what can we write? How do we want to write this? P of x, so 2x, what is it? Now, here's the original, right? The original is constant x, x squared, x cubed. Okay? There's no remainder in there. The original is you've got a constant, an x squared, x cubed. Need a placeholder for everything, right? So if you don't have an x squared, you'll put a 0 in there. So the original was 2x cubed plus 5x squared minus 6x plus 31, that's P of x, is equal to the divisor, x plus 4, times the quotient, 2x squared minus 3x plus 6 plus the remainder. Right? So polynomial is divisor times quotient plus remainder. Okay, so you can multiply this out, right? We'll get a 2x cubed. Minus 3x squared plus 8x squared is the plus 5x squared. Plus 6x minus 12x is minus 6x. Plus 24 plus 7 gives you the plus 31. Okay? So I'm not foiling it out the usual way. Usually I just go through, multiply by the x's, then multiply by the 4's, and then collect. I'm sort of multiplying and collecting at the same time. So I say, give me an x squared term, and then give me the other x squared term. Give me the x term and the other x term. Give me the constant. Okay, because then I can see that it multiplies out to that. All right, so let's do a couple. Right? Should we do a few? For some practice. So, new page. Hang on, let me. Okay, so what do we got here? Let's try 3x cubed plus 5x squared plus 6x minus 4 divided by x minus 2. Okay. Now, if you went online and looked up synthetic division, most of the people doing it will do it by addition. Okay? So, do you want me to show you that?
No.
Because you could choose either way. Okay, we'll do it both ways. We'll do it by subtraction, we'll do it by addition. You can see what the difference is. Okay, well, there's no difference. They'll be the same, but you'll see what happens. You can choose to do whichever. So, because synthetic division, we're not going to test you on this by saying, do a synthetic division on this, right? Or do a long division on this, right? Synthetic division will be part of, I need to do this in order to solve some other problem, and so I just need to be able to show the work. Look, here, I've divided it, and see this, and then, okay, everything's good, and now I'm going to move on. Okay, so by the subtraction method, so, okay. Whoops, extend the L down a bit. Okay, so we've got x minus 2, we got 3x cubed, 5x squared, 6x, minus 4. Okay, so here's the method. Bring down the 3. Multiply. Negative 2 times 3 is negative 6. Okay, I'll go slow. That is 11. 5 minus negative 6 is 11. Multiply by negative 2 gives me negative 22. Subtract. You get 28. Multiply by negative 2, you get negative 56. Subtract, you get positive 52. Okay? So we have a remainder of 52. We have a quotient of 3x squared plus 11x plus 28. The divisor of x minus 2 yielding the polynomial, blah, 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 right? Okay? In doing synthetic division by addition, instead of dividing by the divisor, you divide by the factor associated with the divisor, which in this case is positive 2, right? If x minus 2 is the root, then 2 is the value. Or sorry, if x minus 2 is the factor, then 2 is the root, right? So you're dividing by the root, in this case 2. You still go the 3, the 5, the 6, the negative 4. Bring down the 3. 2 times 3 is 6. Now you add 11. 22, add 28, 56, add 52.
Wait, what?
So the only thing changed was, instead of dividing by the factor, x minus 2, we divide by the root, positive 2, and then we add instead of subtract.
What if there's a coefficient in front of the x, like 3x squared or something?
Can't do it.
Can't do it?
So you can only divide, using synthetic division, you can only divide by an x plus or minus. You can't divide by a 3x or a... Yeah, there are ways, but at this point you're better off just using long division if you have to. So, yeah, if you have to divide, if your divisor is like 2x squared minus 5, use long division. Okay, if your divisor is 5x minus 2, use long division. Otherwise, you're dividing by x minus 2/5, and then you got fractions all over the place. You might as well use long division at that point, right? It's just probably easier than dealing with the whole pile fractions floating around. Okay? So, by the subtraction method basically mirrors the long division that we've been doing, right? Yeah. So do this, bring down, subtract. Do this, bring down, subtract. Those of you that suck at subtracting may want to do it this way, right? So when you go 5 minus negative 6 and end up with like negative 11 because you suck at subtracting, then you might want to say, all right, instead of the factor, I'm going to put the root here, and then I'm going to add. Right? And you can't possibly suck at adding.
That's what you think.
Yeah, doesn't mean you won't get them wrong, but
On the next test.
you should not suck at adding. Okay, so after you have practiced some synthetic division, of which there are some questions to do, right? Then dividing, factoring, and drawing graphs, putting it all together. So all we'll do is we'll do one. This is a worksheet that you've got. I mean, let's do one just to get you to understand. So now, if you're dividing by something like 2x minus 3, use long division. Okay, if you're dividing by x plus 5, x plus 3, other page. So these ones you're going to use long division, the x squared minus 1 as well. So you're going to be doing a lot of long division. You could do a couple by synthetic division. Okay, so we have a polynomial function in simplified form. We got x cubed plus x squared minus 17x plus 15. We get a binomial divisor of x plus 5. We want to write the function as a product of a divisor and a quotient. So y equals divisor times quotient. Now, seeing as there's no remainder here, I'm assuming then when we do these divisions, there should be no remainder, right? In other words, that this should be a factor. So if I want to do a long division here, I could just write x plus 5, go 1, 1, negative 17 and 15, bring down the 1, 5, subtract, negative 20, subtract, subtract. Okay, now you should be ending up with 0 as a remainder. Okay, so write the polynomial y equals d times q, so as a function of divisor, so it'll be x plus 5 times x squared minus 4x plus 3. Write that in fully factored form. So you get x plus 5. Then this should factor, which is what? 1 and 3, right? Anytime you do a factorization, check it out. X squared minus x minus 3x gives me minus 4x plus 3, right? Because if you get the factorization wrong, then everything is wrong after that point, right? And, okay, that's not so bad. Maybe you lose a half mark. I'll get the factorization wrong, or maybe you lose a full mark, because I don't have much sympathy for factoring wrong. So you lose 1 mark because you factored wrong, but you can get everything else right. The problem is, if you turn it, you can turn it into a real mess, right? So you factored wrong, and now you spend a lot of time, and things just don't work out the way they should, right? Because you've basically messed it up. So, you know, what does it take? Just, you know, x squared minus 1 minus 3 is minus 4 plus 3, right? Usually you get signs wrong when you factor wrong. You got the right number. I mean, you can't possibly get 1 and 3 not multiplying to 3, right? And if that's a 12, you can't possibly have two numbers here that don't multiply to 12, right? And if you do, I'm just giving you 0 on the whole thing, right? It's like this couldn't even be a factorization. Not that it's a wrong factorization, it's an impossible factorization. So, you know, at least if you want to lose minimum marks, make sure that these multiply to the correct number, okay? So if they multiply to like 5, then yeah, no, I'm stopping marking now and you just have nothing here, okay? Yeah, 0, like really, you don't deserve anything, right? So check your factorizations, right? If you mix up the signs, worst thing that happens though is that because you're using this to go further on in a problem, is that now everything else is wrong. And it can lead you into a lot of work that shouldn't have been a lot of work, right? It should have just been something that, oh, some stuff canceled down and we're done. And instead, you now have bigger and bigger and bigger expressions. If that happens to you, then you got to figure, I think I might have messed up somewhere, right? If I need to start to turn the paper sideways so I can actually write the expression because it won't fit this way, you know, 8.5 inches, not enough, need 11.
To degree 2.
Yeah, for a degree, yeah, because, you know, you went and multiplied something you should have factored, and now you've got x to the 6th and x to the 5th, you know, and you've got 24 terms out there because you multiplied stuff.
Yeah.
You know? And it's like, no, you should have factored this, it would have canceled, and in 3 seconds it solved, and instead you spent 10 minutes working through a mess of stuff. Anyways, what are the x-intercepts?
Minus 5.
Minus 5.
Minus 5, 1, 3. Minus 1.
Okay, so negative 5, 1 and 3, 3, 1, and negative 5. I don't much care the order you put them in. I just wrote them in the order I wrote these factors. What's the y-intercept?
15.
How can you tell it?
Because of the constant.
Yeah. You could put a 0 in here, right? I mean, I suppose in theory we probably should write these as y equals, but there's not a lot of room, right? But, and what's the graph look like then? What's the end behavior? Okay, wait. First, let's put the intercepts on, right? So I got -5, and you should label them, right? -5, 1, 3, and I got 15. Okay, there's my intercept. Now really there's only one way to draw this. They are all of multiplicity 1. So then the line going through them is just going to be straight, right? Because it's a cubic, so if it was a multiplicity 3, there'd only be one intercept. Okay? It pretty much has to go this way. It has no choice, right? I mean, I can't, if I try and start here, then I have to hit up here before I've hit the other intercept, right? So if I come down, I got to come back up somewhere before I get to 0, and I can't do that, right? So positive leading term, though, says quadrant 3 to quadrant 1. And what else are you going to do? Okay, you're going to put arrows on. Which, if you don't, just costs you half a mark. Each time, because I have no sympathy again for... In regular class, it's always, well, what do we take off? Oh, well, 1/2 mark once for no arrows. Yeah, in IB, it's like 1/2 mark every time you do it, because if it doesn't hurt, you'll keep doing it. And you need to be hurt, I'm sorry. But if you're going to make stupid mistakes, you need to feel some pain on it and say, oh, I lost like 2 marks on that test because I didn't put arrows on things. Right? What's that mean? It means the next test, you'll remember to put arrows on things. Okay. Be an arrow. Okay, so you should be able to go through the rest of these, right? You will have to do long division for most of them. You will probably want to do that on a separate sheet of paper. Actually, you probably won't. You probably should do that. Okay, thanks. You should do it on a separate sheet of paper because it's hard to squeeze a long division into here. Okay? And if you do, all it means is you're going to do it sloppily on the test. Because the way you do your homework is the way you're going to do the questions on the test. So when you're doing your homework, if you don't always write y equals, then when you do the test, you're not always going to write y equals. If you just take shortcuts with, I don't want to write that denominator because it appears on 5 lines, then on the test, you won't write that denominator because I'd have to write it 5 times. And you will lose marks because you have to communicate mathematically properly. Right? Every line has to follow from and be able to be going back. When you're working your way through a solution or something, you need to go forwards, but you also need to be able to go backwards. Okay? If I do a certain thing, then that's what follows. Like, how did I get from this line to this line? Divided by x plus 2. How did I get from here to here? Multiply both sides by x plus 2. And you'll get that, right? But that's going backwards. So lines need to be full and complete in a solution. You can't just go sloppily, I'm just going to leave stuff off. Okay? All right.